My third and fourth years at Tesla, again, after really getting the Gigafactory up and stable, I was able to move over into the R&D division and formed a new group within the R&D set. And I ended up calling it the Battery Cell Material Processing Group. So at Gigafactory, like I mentioned, you really do receive these refined cathode and anode powders into the building. You don't really get involved much upstream of that. And when you look at actually assembling the battery cell itself, only about 1/4 of the total cost is the manufacturing. So with Gigafactory as an example, about 3/4 of the cost of manufacturing a battery cell are spent really at the loading dock, buying those highly refined materials to just come into the factory to then be assembled. So my third and fourth year in that group I formed in the R&D division, I was able to go out and hire 7 or 8 R&D engineers, mostly PhD chemical and mechanical engineers. We were able to build our own wet chemistry development lab within the company. And instead of just buying those highly refined materials from the market, we started receiving raw ore samples, raw brines from different sites throughout the world. These were undeveloped mining sites where they had large amounts of lithium and cobalt and nickel bearing material. But to date, those elements weren't being harvested because the conventional mining community had determined that they weren't economical to extract from those resources. So we started receiving drums and barrels and dry sacks of these different types of unconventional materials, developing our own processes for how to extract those individual elements, new ways to then purify those extracted materials, and then actually synthesizing new active cathode materials and testing them in cells against what we were getting from our own supply chain. So now that we're looking at this recycled material, once we have essentially the scrap metal separated, that black mass concentrated, what remains is really an unconventional resource. So myself and many of my old team from Tesla who have come over to ABML over the past few years are now looking at that with a similar lens and saying this type of black mass is really just another type of unconventional resource that is bearing lithium and cobalt and nickel and manganese. So again, we have our own development laboratory. We've been trialing really first of kind processes for how to extract these elements from this type of black mass. And when you look at the emissions from these types of facilities, at the front end, if you use a very high temperature smelting based process, you're essentially burning and melting a battery pack up front. That releases very large amounts of toxic air emissions, toxic water emissions, and these are not just greenhouse gases. These contain large amounts of sulfur and fluorine and phosphorus and heavy metals in particulate form. These are real toxic emissions. And by us doing this strategic demanufacturing process, we don't have any single operation on site that runs at high temperature. There's no combustion anywhere on site, so we avoid that entire set of emissions. And then on the back end process, when we're extracting one element at a time, many of the emissions there, they're called tier 2 emissions, where it's really not at the plant itself, but traditionally very large amounts of chemical agents are used. Industrial acids and bases and oxidizers and solvents that are used to extract these metals. The process we put together is able to use dramatically lower amounts of those chemical agents, which reduces the total life cycle footprint of our process. So again, when you look at our system, it really is a night and day environmental input for the same amount of products coming out based on competing processes.